we're here asked to calculate the slope of the curve. Now, slope gradient means we've got to find dy dx, and the curve is x to the fourth plus xy plus y to the fourth equals 1, so it's an implicit function. Difficult to get y by itself, so we're going to use implicit differentiation to find dy dx. At the point 0, 1, so we'll get a rule for dy dx, an equation involving y dx equals, so we can substitute in for our x and y value to find the gradient, and then we're asked to find the equation of the tangent. So given the fact that we've got 1 point and we've got the gradient, we'll be able to find the tangent. So let's go through our template that for differentiation, so for implicit differentiation, the first step is to find with respect to x of every term. So we've got d dx of x to the fourth plus d dx of xy plus d dx of y to the fourth equals derivative with respect to x of 1. We can calculate all those. So derivative with respect to x of x to the fourth is 4x cubed plus, now here we have a product of two functions, x is a function, y is a function, so we'll use uv, so it'll be uv dash, so it'll be x dy dx, so that's uv dash plus u dash will be just equal to 1, and v will be y. So that's the derivative with respect to x of xy plus derivative with respect to x of y to the fourth. We have chain rules, so you find the derivative with respect to y of y to the fourth, so that's 4y cubed. And then we find the derivative with respect to x of y, which is just dy dx. Derivative with respect to x of a constant is 0. Okay, so the next step is to all dy dx's on the one side, or not so much on one side, it's on the left hand side, LHS for left hand side. So here's a term with dy dx, here's a term with dy dx, so we'll get them on the left. So we've got x dy dx plus 4y cubed dy dx, so 4 over there. So the other terms containing dy dx, so we get everything else to the other side, minus 4x cubed, and the plus y when it goes over there becomes minus y. Number 3 is to factorise, so we'll have dy dx outside of some factor equals something over on the right hand side. Dy dx is common to both of those, so it'll come outside of those two terms. What have we got to multiply dy dx by to get that? Or just x. The plus sign comes down. What have we got to multiply dy dx by to get that term? 4y cubed. Right hand side hasn't changed. And final step is divide by a. And you do that both sides, so we're going to divide by both sides by this to get dy dx by itself. Minus 4x cubed minus y all over x plus 4y cubed. Now that's just finding the equation that has the gradient is equal to this. So if we want to find at 0, 1 dy dx equals, we sub in 1 for y and 0 for x, so that'll be minus 4 0 cubed minus 1 over 0 plus 4 1 cubed, and that'll be equal to negative 1 over 4. So that is the gradient at the point 0, 1 on the curve. Now we're asked to find the equation of the tangent. Now, given that you have the gradient, so that's, if you like, is my m, and we've got a point on the curve, so 0, 1 is equal to x1, y1. From memory, you should recall that the equation of a line that passes through x1, y1 is y minus y1 equals m outside of x minus x1. So given that it goes through x1, y1 and has a gradient of m, that's the equation of the line. We've got m, we've got x1, y1, so we just substitute in. So we've got y minus y1, this is my x1, y1, y1 is 1, equals m minus a quarter outside of x minus x1, which is 0. And if we play around with that, we get y minus 1 equals minus a quarter x, and we take the minus 1 to the other side, we get y equals minus 1 quarter x plus 1. So that's in the form of y equals mx plus c. So going back and just doing a recap, firstly we need to identify that we've got implicit differentiation going on, and when we see the word slope, we know we're talking about the gradient, which means we've got to find the derivative. And when we've got implicit going on, we find d dx, we put all the dy dx terms contained on one side and then all the other terms on the other. We then factorise out the dy dx, divide both sides by the other factor other than dy dx, which in this case was x plus 4y cubed. And then we can calculate the gradient at that point, and we use the fact that given that we know the gradient and our point, we know that this will be the equation of the line that has that gradient and passes through that point, and we can just substitute in the values and get in the form of y equals mx plus c.